We will listen to a presentation now from the CEO of Gapwaves. And Gapwave creates antennas that enables superior 5G solutions for the telecom industry and safer radar solutions for the automotive industry with an innovative waveguide technology. Let's now listen to the CEO, Lars Inge Sjöstedt. He's with us here at Grand Hotel in Stockholm.
Yes, thank you very much for the introduction, and thank you very much for inviting me to this Naventus technical summit from Naventus side and also from Jonas. Yes, I will talk about Gapwaves and give you an update on that and where we are today. Our terms here is 5G autonomous driving, and they are run on antennas. I just want to say that everything which is wireless is always driven on antennas. And that's the key we hold in. Going a little bit back, the company is not so old. It started 2011. It was a professor, Per-Simon Kildal, at that time working for Chalmers University. He is the inventor of the technology as such, which is the Gapwave technology. And he founded the company, and since then we started to do some things, but it was quite early in this company's phase, and we now, 2016, entered the stock market, and we are listed, and that was an IPO we made at that time. The share price when we entered the market was 5.95, and I was looking in today, it was 43 krona, so it has been quite a good growth over time. So the market cap today is about 100 million euros. What is important when you come with new technology to the market? Yes, it's important to have patents. And that's something Per-Simon started early with, and we have continued. So today we have over 25 different patent families to protect our inventions. And it's very much about antennas. That's the focus we work with. And we are specialized both in the area of telecom, but also in the area of automotive radars. And I will come back a little bit more to what we do in these areas. The technology as such, it's unique in the way we can combine manufacturability, cost, and performance. This is the key. Saying some word about frequencies, because everything going in the air is by radio frequencies starting at, quite low, some 100 megahertz, and going up the whole way to over 100 gigahertz per. That's what we are seeing today. And most of the telecom things working to the telephones are really on the bands up to 3 and about 3 gigahertz. But we are more interesting when we come up to higher frequencies. You find typically things, as we call it, 5G in the 28 gigahertz arena and higher. And in these cases, the losses with the traditional patch antennas are quite high, but we in these cases can give a lot better performance because we do not have any losses in the antenna. And specifically, we today see a very interesting growth in the area of automotive. 77 gigahertz and up to 79 is a band which is dedicated all over the globe for automotive industry, for radars. And in this high frequency, it's very important to not have so much losses as you have in the traditional antennas. So again, I've been working through this sometimes now over the years, but I think it's worth mentioning again. What we really can do for our customers, we can lower the losses for the performance of an antenna. We can also, because we can use the mechanicals here, like metallic areas, we can also have easy to take away the heat from the components. And together with the technology, it's also possible to make assembly and multiple layers, which can give these antennas a very unique performance and also what the customers really want to have. And what we now have proven is also it's possible to do this in high volume production. And we do it for automotive radars. So we are talking about million units possible to develop and also to produce to the right price. If you compare a little bit with the existing technologies, most antennas are made by PCB, some sort of PCB, and you have what you call a patch antenna. This is a very good technology for lower frequencies, but when you go higher and higher, it becomes a bit lossy. And the best thing up there is what you call a waveguide antenna. And you can see here a typical waveguide solution based on a rectangular waveguide. But that is quite complicated to produce. And we can combine these two things with a very good technology for production of waveguide antennas. So we can combine it and then also get a lower cost than PCB antenna, for sure. In the 5G area, we typically see that we can help with what we say longer range when we talk about these 5G solutions on 28 and higher frequencies. And the lower losses also means that it will be less consumption of energy. And also less components, which is another good thing for our technique. Going to the other area we are working quite a lot with is the technology for antennas to radars, to the automotive industry. And here we typically can see that a radar, as you have seen it in your car maybe, it's working like a distance pointer, but it also gives you more and more information about if there is anything in front of you or besides you, which can be very dangerous for the car. Knowing that more than 1 million people, I think it's 1.3 million people today, are killed in traffic. It's quite important that the security will be better. And the radar solutions is the best way to make this happen, really, on the market we have seen. Cameras is good, but they are not so good when it's foggy or it's rainy. It could be a LiDAR, but that's also light. So it means that it's not so easy to use when it's foggy. What we can give them, and we know this, that's the better gain they can get from the system. As we have written here, it's also proven in many cases now that we can really give them 5 dBi better performance compared with a patch antenna on the 77 gigahertz. And this is a lot for people who know what I'm talking about. And it's not only radar, we also see another vertical coming up more and more, and that's what we call these kind of robots running on the streets to deliver package. Last mile delivery, we call them. This the map showing a little bit about the customers we are approaching, because we don't sell this to the end customer, of course. We sell it to companies who make these radar solutions for cars, or telecom. In that case, this is most the base station providers. And typically we see that both these markets, only on antennas, is in the size of 10 billion SEK 2025. And that's quite a lot for a company in our size. Some of the names here are well known, of course, and they are very big companies going for the telecom side. I know that Ericsson, together with some others, are taking like 5 companies having the most of the Earth really telecom base station solutions, selling them. So you find also Nokia, Huawei, Samsung on that map. But it's a very few big players, I would say. Going to the automotive side, we are not selling this directly to Mercedes or BMW. It's the tier ones who is really the customers for us, providing the radars for these customers. And here you find typically Continental, Bosch, Magna, Huawei, Dentsu, etc. There are 10 companies, but 5 of them are also taking care of 80% of the full volume on the market. And the number of radars today is in the level of 70 million units per year, and the prospect is that they will grow up to 300 million units already 2025, because it's very important for the safety, security of cars. Here is some example of the products we are doing. In the middle, you have the telecom phased array antenna for 28 gigahertz. The other one here is an automotive radar just for testing. It's not looking like that when we do it as a volume product. And we are also into some high hotspot 5G solutions for 28 gigahertz. They are smaller to be inside or in urban areas, so to say. Some breakthroughs to mention here for the company. I started this year in January to say that I think 2020 will really be a breakthrough year for Gapwaves, and I fully still say that that's what we are doing. Last year we had Veoneer as a customer. They have licensed our technology for doing radar antennas. Veoneer is one of the big ones for supplying radars to automotive. Another one we haven't disclosed the name of because they want to keep it secret is a tier one of the big ones. And they have been working with us now for over 2 years, and we are providing them more and more technique really to become the main supplier in this area. And that's quite fantastic. We also sold some 5G 28 gigahertz phased array antennas to a Japanese company during this year. There are another big company coming up called Under. They are not so big as such, but behind them we find one of these global tech giants who has ordered a number of robots for last mile delivery, and they supply them today with antennas from Gapwaves. So we have just now delivering to this order of 4,000 units for robots, and still it's prototyping. It's not the full product. On the 77 gigahertz radar, we have another supplier called, a customer called ZF. They are quite big as well. It's a tier one, and also Infineon have tried and tested our technique now and is in the next phase of see what they can use this for. Because all they see is that we really make sense and a difference in the sense we are talking about here. And just before summer, we also received an order from directly from one of these technical giants in the earth. I don't say from which country because it's best to keep it secret. And it's still on 77 gigahertz radars. So there are many interactions with customers going on at the moment. And the last thing was also a prototype order for a 28 gigahertz radar solution, so not radar, but phased array solutions for a US-based antenna provider. So that's the last one. And there are more to come. Looking to the priorities for this year, it's very much about agreeing long-term contracts for sure, because Gapwaves is still a small company. We are 30 people working in Gothenburg, and of course we need to have these contracts for long-term coming up. We have a development of performance of the products, of course, because we need to also see that we fully can make them in reality, so to say, in production. That's another part. And also we want to establish a big footprint also in the 5G millimeter arena, because that's important for us long term. Together, to summarize this, we have a very interesting technology which really makes sense for a number of large companies. The patented technology is also important. It's not so easy to copy. The market size, I think, is quite big. If you compare to the size of Gapwaves, I would say the market is enormous. And what we really have is the possibility to produce high volume in these areas. And this is unique because there is no other one who really can make these type of antennas in these volumes to the price and performance we can show. So that's my presentation of today. So yeah, Katarina, please enter the stage. You wanted to say.
Thank you very much,
Give me some
Lars-Inge.
questions, I think.
Yes,
Yeah.
we have gathered some questions from the viewers that were sent
Okay.
in before the event. And the first one goes like this. How are Gapwaves antennas better than the other new 5G antennas on the market in terms of price, size and performance?
As I said in my presentation, what we can do is that if you go for a patch antenna, which is what we really have on the market today, then you drive the waves, so to say, in the plastic layers. In our case, we drive the waves in air. That means the losses becomes almost zero. So for every type of antennas we can do in our technique, we always have the best performance, and we can also produce them now for fully.
Because of your unique technology.
Yes.
Thank you. Another question here. Will you license out manufacturing, and if so, to what extent? For instance, all the way to the end customer or just the manufacturing itself?
There will be different solutions on this area, and we are already approached, as you have seen, with Veoneer, wanted to have a license to produce themselves, but we have other customers who want us to produce things for them, together, of course, with some partners, because we don't have the factories at Gapwaves today. And there could be a combination as well. And we haven't been locked into any of these, because we think it's important that our technology really be the ground for the future. That's important.
Well, thank you very much, Lars-Inge from Gapwaves. Thank you.
Thank you.